Hi guys, excuse the voice, I've just come back from Greenside. So I've been teaching there already. And you might say, aren't you cold? Well, I was wearing a jacket, I've just taken it off now. Now, guys, when we do return to school, and I saw that, I don't know if you saw, I think I got an SMS that it's provisionally the 6th of July that they want the grade 11s to come back to school, provisionally. Won't have time to reteach everything, so we will just carry on to wherever I left off. All right. When I finished all my teaching today, I will do this memo. I haven't even had a chance to look at it. And even if I only send it tomorrow, I will send it to you. My memo will be step for step with reasons. So you might have found the last two a bit challenging because they're always a bit harder. But rather, let me carry on with the syllabus. Once you've seen my step for step memo that I'll post on the group, then you could always then say, SMS me and say, can you explain whatever on Monday, which I will. I also just want to bring to your attention that the time will be changing on Wednesdays for your Zoom lesson. I cannot tell you how at this point, but they've moved the periods up. So I've got a feeling it will actually work in your favor that our Wednesday Zoom will be later, like 12 or 12:30. But can I please confirm that with Hajja, and I'll put it on the group. I just want you to remind me something is happening that's different on Wednesdays from next week. And just before I start teaching, after today's lesson, I will see you on Monday and then again on Tuesday. And both of those lessons are at the usual 12 o'clock. So you could just remember Monday and Tuesday is 12 o'clock, and then something different's happening on Wednesday. I'll let you know. I've got to actually speak to Ms. Klitter just to finalize the Wednesday. Okay, so guys, I want to show you something new. It's Friday the 19th of June, 2020. I don't think you'll forget the year. And we are carrying on with Circle Euclidean Geometry. Okay, so now what I'm going to show you are two new concepts. Now, the first concept I want to show you, everybody watch here, I'm going to put in the center. So if we look at my diagram 1 on the left, I'm going to say, given, and of course I'm telling you, O is the center of the circle. Now, do you all agree that this line would be called a what? Okay, it's meant to be straight. My ruler is playing up with me. Okay, so if it's on the circumference point A and that's point B, do you all agree we call that a chord? Good. Now remember, chords break a circle into segments. Above this chord, all of that part of the circle is in the same segment. It is the major one, and then all of that below it is the minor segment. And please don't forget about arcs. Now, I could also refer to this as, I told you, arc, A-R-C. I'm a bad speller, but here's my glasses. But I can tell you now that is how you spell this arc. Obviously, that is the minor arc. There would be a major arc there, but, you know, I'm trying to just explain a concept. So now, let's say that this particular chord or arc is going to hold up an angle at center. Do you remember that fancy word for a chord or an arc to hold up an angle? It's got a fancy name. That would be to subtend. Okay, so the word subtend, it's a verb, is just to hold up. All right, so I'm going to say to you, see here we have chord AB, and if you go along the perimeter of sort of the lines to the angle, let's pretend this angle here is 80 degrees. All right, I'm going to call it angle O1. So I'm going to, in the given, I'm going to say angle O1 equals, because remember, angle O2 would be that reflex angle there. I don't know if you can see my one. Let's just make sure you can see it. This is angle O1, and this is the center. Right. And I'm telling you that angle O1, this angle, is 80 degrees. Okay. Now, if that exact AB holds up an angle, now watch. It's got to be at circumference. It doesn't have to be directly on top of it, but what I'm trying to say is, look here, fingers are very useful for this section, I promise you. Put this point of the chord, there's the other. Chord are holding up this angle at center, and I'm saying for now it's 80 degrees. Pretend, it can change. I could say tomorrow or in the next question that angle is 80 degrees. But we're not measuring it. You just got to, it's just like you got to believe me that I say, okay, let it. But you see the same chord or arc is holding up, or we could say subtending, an angle at the circumference. So let's make this point of contact on the circumference C. Now this is very interesting, so watch carefully. If you have that arc or chord holding up an angle at center, and that same chord arc subtending an angle at circumference, but it's got to be in the same segment. In other words, above that line. It can't, we're not talking about in the minor segment here, we're talking in the same segment. Then you would know, if I say that is X, and I said determine X, you would know exactly what it is once I've explained the rule. So angle X will always be half of what you have at the center. Okay, it's a rule. I'm going to prove it to you. So I'm going to first just do it and then I'll prove it. So I would say X is 40 degrees. Why do I know that this angle X is 40 degrees? Your reason is that stands for angle. You are welcome to write an angle like that. Angle at center equals 2 times the angle at circumf. Circumf is abbreviation for circumference. That is the reason they want you to write. Don't invent your own reason. You've got to learn these. Now, if you forget which one is the bigger, just look at me right now. When you get older, you always get bigger in the middle. It's called your tummy. When I was young, I had a flat stomach. 3 kids later, I have a marshmallowy, not a choco-block, a marshmallow stomach. So just remember, it's always double in the middle, at the center. So if you are given a circle, they tell you always center, and you see you have an arc. Now remember, sometimes I said this happens. Remember Harry Potter, Expelliarmus? That chord might not be drawn in the diagram, but it doesn't matter. As long as you have 2 points on the circumference, that is still your arc, AB. So we don't even have to see the chord. So it's still the arc is holding up or subtending the angle of 80 degrees at center, and that same arc, AB, is subtending an angle that will be exactly half, but it has to be at the circumference. Okay, now I'm going to do this exactly again, but I'm going to deliberately confuse you. Watch the board. Do you agree here? Here is my arc, A, B, all right? I'm going to give you O is center. So O is, this is given, center, O is center of circle. They could say AB, that just means we know that A and B lie on the circumference. All right, now watch this chord, or remember the arc, AB, is going to be subtending that same, I'm going to make it, let's make it different, okay? Let's make it 50 degrees, all right? So we'll call this angle O1. So I have to say angle O1 as part of my given equals to 50 degrees. Now watch what I'm going to do next. I'm now going to go like this. Okay, so that's still on the circumference. Sorry if it doesn't look good. And that is my point C. Now let's make this Y. How much is angle Y? Now, optical illusion. Because if you look at this diagram, let's just put my chord back in. Do you remember I said if an arc or a chord subtends an angle at center, then as long as it's in the same segment, if that same arc or chord subtends an angle at circumference, we know it's going to be half of what's at the center. Now, all I've done is I've like moved C down there, okay? But if you analyze it, that's why please use your fingers. This chord or arc is subtending the angle at center of 50 degrees. Go back, that same, as long as it is the same, it's badly drawn, but that same chord or arc is subtending an angle in the same segment at circumference. So I know that Y is going to be half of the angle at the center. So that little y will be half of 50. What is my reason? It's the exact same reason. The angle at the center times the angle at circumference. Now remember, we have the CAPS reasons and they don't accept other reasons. You've got to learn this reason. All right, now let me therefore show you why this is the case. And to show you why this is the case, I'm going to do the proof. Now remember, all proofs are examinable. So the proof I'm going to do could be the proof to prove at the end of the year. But this is something you, when we do this, so let's say, so it's theoretically your proof. Because theoretically I did a 1A and a 1B, and we could call this proof theorem 2, but I'm just saying at the end of the day, this is the third proof. Now, they're going to put in the center, they're going to do this, and they're going to do this. Okay, AB, and then this is the easiest way you could get this proof. They could make it harder for you, but we won't look at that today. Okay, AB, and let's make that C. Now I'm going to call this angle, well, actually, you know what? Don't call it anything yet. Don't call it anything yet. They will get, there's a huge possibility they give you this diagram. They will say, given O is the center of circle, but then they're going to say, they want you to prove that the angle AOB, look here, angle AOB. So prove this angle equals to 2 times this angle, which would be called ACB. Okay. So if this is the bigger one, we want to prove this equals 2 times that. And that makes sense, right? So I have taught you that that is something you learn, but now I'm going to do the proof. With proofs, you always do a construction. So the construction we're going to do, which you need to write it up. You need to say, this is my construction, if I spelled that right. And you need to do the construction in the actual diagram, on the diagram, okay? You're going to go from point C, you're going to join through O and extend this line, but just extend it not past the chord, just extend it to any point there. You can call it point D. Just don't call it A, C, or B. So your construction is just to join C-O-D. Literally, that's what you're going to do. Now, by doing that, you can't assume this angle is exactly equals to that. I'm not doing what's called bisecting. I'm just drawing a line. So I'm not saying that is equals to that. We didn't say bisect or anything. We just said join from C to O to D. That's it. But do you understand, by me doing that, this is now angle O1. This angle here is O1. This angle here is now O2. Do you understand? And this angle here would be angle C1, and that is angle C2. Now remember, you get this diagram, you've got to learn which construction to do, and if you don't reference your angles, if you refer to angle O2, but you didn't put the 2 in the diagram, they will not mark it. So remember, what I'm doing now is a proof. Let's see how interesting this is. I actually love this proof. This is, I think, one of my favorite proofs. What I'm going to do, I'm going to now write up the proof. Okay, once I've written my construction, I run out of space. I'm just going to finish it here. We're going to let angle, now this is also, if you want to, let's call this, think about it actually, I'm going to call this angle A1, A2, B1, B2, because you can't say angle A where there are 2. Understand? I'm with A1 equal, and I'm going to put that in my diagram. So I'm going to say to my examiner, let that angle be X. Now, I will first just write up to explain it. This says me who got the opposite. Trying to all see this, all right? Now, from O to A is a radius, and from O to radius. Have a triangle like this, and here to, let's say, A, and let's say that's the O here. If these two are equal, then these two would be equal. Remember, you have to say angles opposite equals. You should have been thoroughly trained about that reason. So whatever two sides of the triangle are equal, the angles opposite those equal sides, those are the two angles that will be equal. So, yes, then we'll see what that piece, all right, will be the same one. Because do you all know that therefore I have an isosceles triangle, but you can't say that. So you will now tell the examiner angle C1 will equal to angle A1, which is X, right? What was our reason? You go angles opposite. Now we normally go equal sides, but if the sides are radii, equal radii. So what you could do, you go angles opposite sides, radii, if you would rather just do that. If the two, that are equal are radii, you will always get an isosceles triangle, and therefore those base angles are equal. So you can choose which you prefer. Some of my memos might say that, and the more updated say that, because the quicker you can write your reason, the better. But remember, you've got to learn that reason. Now, the next thing I'm going to do might confuse you slightly, but do you remember learning about the exterior angle of a triangle? So if we have that C and that A, and let's just make that O, okay? So let's say we got that triangle, those are equal, so let's say that is X and that is X. If you extend one of the sides, do you all remember that that is called your exterior angle of the triangle? And that exterior angle equals the sum of the opposite two interior angles. So that angle there would be 2x. So if this angle here is x, and this is x, and we're looking at triangle ACO, do you all agree that angle O1 would be 2x? Okay, I don't know if you can see that angle. So I'm going to now tell my examiner that angle O1, therefore, angle O1. Okay, remember there's a solid line here, so I'm just referring to O1, because I can't quite fit that in there. You will say angle O1, therefore, is 2x, and the reason for that, why is that 2x? You just say exterior angle of, and I always name the triangle ACO, exterior angle of triangle. Now, what we're going to do next is exactly the same, but on the other side of the triangle. So watch here. I'm going to go also, you could say similarly, but I never know how to spell that. I'm going to let angle B1 be Y. So let angle B1 equals to Y. Now look carefully. We have OCB, which is a triangle. OB is a radius, and so is OC. So therefore, it's an isosceles triangle. And therefore, that's radius there, and that radius there. So therefore, can you see that angle C2, just that part, would equals to B1? Okay, so let's say, therefore, angle C2 hat equals angle B1 hat, which equals to Y. What's my reason? Okay, that is angles opposite equal radii. Okay, we're getting somewhere. Now, just like it happened on the triangle on the left, do you see we have this triangle? I'll say it again, triangle BCO, look carefully. If these two angles are Y and Y, then do you all see O2 would be 2Y? This angle there, okay, because of your exterior angle. But of which triangle am I talking? Of triangle BCO. Okay. Now, unfortunately, wait, I left the triangle out. Sorry. Okay, triangle BCO. Now, as you can see, that is the end of my board. And I've literally now got 2 lines left, but I've run out of space. So I'm very sorry, this is not very professional, but I'm going to continue the rest of my proof here. I apologize. Continued. Okay. Now I want you to all look very carefully. Do you agree, therefore, angle AOB, this big angle, which is O1 and O2, if I add those up, do you all agree, therefore, that angle O1 plus angle O2, do you agree what equals to 2x plus 2y? Now, you don't need to give a reason because you've said who's x, who's y. So that statement is actually already found, proven, done and dusted. But what you do next is, so therefore, angle, look carefully, O1 plus angle O2, let's factorize this by taking out a 2. You see, both of those terms have 2. So if you take, you get x plus y. So therefore, angle O1 plus angle O2 equals to 2 times, now look carefully, do you see that this angle AB, which I'm calling C1 and C2, if you add that up, all right, x plus, sorry, I want to say it is x plus y, but what I want to say though is it's 2 lots of angle ACB, because angle ACB is x plus y. If you want to write that, angle ACB, you can see in the diagram is x plus y. So that x plus y is angle A. So basically, if you O1 plus O2 is the angle that they wanted. AOB is O1 plus O2, and you see it equals to 2 times ACB. All right? Now, when I do this proof, I do it a little bit faster. I'm going to do this proof again on Monday, so you can 100% see it again. If you look at your textbook, and I haven't even had a look yet, let me just see what they're going to do here. All right. There's 3 variations of this proof. Please do not worry about these guys, but you will see here that they do it slightly differently because they don't bring in x's and y's, okay? Yeah, anyway, I guarantee you the way I have done it here is totally easy to remember. Okay, so what I'd like to do is I will redo this proof on Monday, and I'll make sure I start higher up, and I'll do it once down. I will also send you the proof on the group, okay? But if you remember it, let's just quickly rub this out. I'll just quickly show it to you.
10
Yeah, how many minutes? Yes.
10 minutes left.
Thank you. Who is that? Haja?
Yes, ma'am.
Okay, Haja, did you understand what I did or a bit?
I mostly understood.
Okay, so I just want to show you again. I just want to talk you through it. Just quickly talk you through it. We'll rewrite it just so that you can see it one more time. So remember, they have to say given O is the center. All right? Then they have to somehow mention that you have a chord. Okay, so A, B, let's just say chord A, B. You know, they can word this how they want to. And then we're going to have a point. The easiest option for now is above it, straight above it. Let's just keep to this one, call that point C. And they are going to say, can you please, oh, then they will join this up, sorry. They're going to say, will you please prove that angle AOB, so that's the angle at the center, angle AOB equals to 2 times angle ACB. Now, I've told you that that is the truth, that a chord or an arc, if it's a tangent angle at center, it will always be double the same chord or arc subtends at the circumference, anywhere actually above that chord in the same segment. So if you remember, without writing this all down, my construction was to join CO and extend to a letter. Let's just make it P. That is angle O1, O2, angle C1. Let's call that angle N and B1. You don't even those angles, all right? So if construction, just literally join COP. I angle ABX, therefore C1 radii, right? Those angles opposite here on the left, this blue angle, this one side red has been extended to point P, which makes this exterior 2x, because that exterior angle of the triangle. And I said, similarly, let that be y, because that is a radius and it equals to that, then that would be y. And you would say angles, then in this red triangle, you see produced, so the exterior angle would be 2y. Then those up, you get 2x plus 2. It's the sum of those two angles. And if you take out the 2, you're left with x plus y. Now this angle here, if you add it, angle AC is x plus y. So it is therefore the angle at the center, AOB, times, remember you're factorizing that, angle CB. Okay, but you have to write that up very, do that sometime this weekend and I'll put it on the group. Guys, if you want to look at your textbook, well, that's my dog Pi. Your text, as I say, we're looking at approximately, you know, they did the proof, but very differently to how I do the proof. I understand it better with a bit of X's and Y's. I put X's and Y's in a lot of my proofs. They, on page 216, they do very easy examples, and you'll see angle at center equals 2. They do some more, and then they give you a few to there. Now, let's just stick to read. Just do literally exercise A, B, C. All right? And maybe that just do A, B, C, D. It will take you 1 minute. I promise you. So I'm giving you 4 just to read the worked example. They give you worked examples first. So example 3 and example 4, they have done. So just checks them out, read reasons, and then do A, B, C, and D. This weekend for you, this memo, and I will write that up beautifully, and then you can print it out or copy it down. Sign off, even if we have 5 minutes, I'll give you a 5-minute. I was planning to do another rider example. I think let's keep it simple. Let's do that on Monday, because then I'm bringing in a little bit more. But I think we've done enough for today. Important is just read the textbook. You'll see, don't go further than D of exercise 2. It's not hard. It's just new terminology, but it's not hard. And I love you all. I'll see you at 12 o'clock on Monday. Okay. Bye, guys.